Hey everybody, Devi here. So I'm starting a new series called AWS RAR series, or it's AWS followed by 3 Rs, which is AWS Repo Review Rebuild series. So here what I'm going to do is I'm going to pick one AWS GitHub repo, go through it, understand it, review it, and then try to rebuild it. So that's the whole purpose of this series. So I'm going to start this series with my very first project, which is all about understanding how Bedrock works. So in this particular project, I picked this repo from AWS Build On repo. The authors had done an amazing job of documenting every single detail of how it works. So here the use case is that we're going to build a Bedrock agent that's going to be capable of looking through a URL that the user submits and scrape the relevant information that's required by the user. So here again, the model that I'm going to use is Claude Sonnet. So that is the same model that was used by the original AWS authors as well. And we're going to create an agent that's going to do this web scraping for us. So before that, the whole point for this intro is what are agents and how do they differ from RAG, right? So you can think of Bedrock agents as these smart assistants, and they are capable of doing two things. They understand tasks and they're able to take actions to complete those tasks. And there are two core components of these agents that make them super smart. The first part is system instructions. So these are like the high level command of what is expected out of these assistants. For instance, it could be a research analyst uh, who's expected to perform accurate, detailed analysis for your research thesis. That could be a system instruction, or another fun system instruction can be you are Professor Dumbledore, so answer like him and take up his persona. So that's another. So system instructions can be anything at all. It boils down to your use case. So system instruction is one part of it, and the second piece of it is action groups. Now, action groups, they are gonna hold the logic behind how these specific functions are going to be done. In our use case, we are going to have an action group called web crawler, and that's going to hold the task definitions of how it's going to go and scrape information from these external websites that are provided by the user. So enough talk. I'll give you a quick demo. All the links that I've mentioned, the original repo and my GitHub repo, all of it will be included in the description below. So yeah, we'll get started. Hey everybody, this is a really quick rundown of the README files from my GitHub repo. Before that, a huge shout out to Build on AWS Bedrock Agents web scraper repo. So this was the big inspiration behind what I did. So I actually went through this and then I decided to implement it and tweak a little bit of it. So what I did was just change the Streamlit interface, and then I also made modifications to use just one action group instead of two action groups. So yeah, before I get started, huge shout out to these guys. And I've also included their link as part of my README file. So yeah, quick rundown of what's happening here. So for the first part, which is setting up Lambda and Bedrock, I went the console route. So I went into AWS Lambda and I set up the Lambda function. And one nice thing that I want to call out is you can use Amazon Q to also ask it to explain what all of these different functions are doing. Like for instance, the brain behind this, the main function here is the handler function, which is called Lambda handler. And that's going to be the entry point, and it's the one that's being called when function is invoked. So it lists out all the functions that are used. That's a nice thing that I wanted to call out to understand the logic that's happening here, the Lambda function. You then add a Lambda layer So the layer is something that takes care of external dependencies. Now in this web crawler project, we are using external things like Beautiful Soup, which helps with the web crawling capability. So we want to keep our Lambda function light for the main logic, and the dependencies are being taken care of by the Lambda layer. That's the Lambda layer, Lambda piece of it. Let's then move on to the Bedrock version. So you go to Bedrock and you set up Claude Sonnet as the model, you give system instructions, and then you go to agents and you kind of define what your action group is and what exactly is the logic behind how the input received from the user should be processed and what the output should look like. The simplest way to think of it is that so you have, as part of the agent, you will also have a web scrape JSON schema. So that is going to define the contract. The agent will be the contract enforcer and Lambda will be the contract implementer. So that's how the Bedrock agent, Lambda, and the whole web scraping schema that you define as part of crawler agent all work together. So the last piece of it is, you make sure that everything works together and you go into the console and you test it out. So you say, in my case, I'm using this, I'm a new Fuji user. I got my XS20, so I'm all into recipes. So I found this awesome website called Ross and his JPEGs. So I'm going to use this as my target URL, and I'm going to ask Bedrock to tell me about Jurassic Jade recipe. So it's this nice recipe here, which is beautiful to capture anything that's green. So it gives me a nice response and I know it works. So now that we know that the agent works and Lambda function works as intended, we can go to the second part of the project, which is EC2 implementation. So for this, I again used the OG AWS project here. So I used the YAML file that they put together. And the only difference that I made was with the interface, the way the pictures look and all that. So I just made tweaks to the interface of interface piece of it, but other than that, everything else remained the same. So I went into CloudFormation and then I created a new stack. I uploaded the EC2 Streamlit YAML file and it created this CloudFormation stack. To run the Streamlit app, I did a EC2 instance connect. I went into it and I made sure that I did a sudo command to go into the invoke Python file in particular, and I updated the ID of Bedrock and the alias ID. So you can get the Bedrock ID and the alias ID when you scroll down here. So I made sure I went into the invoke Python file and I updated these two IDs. Again, you can walk through my README file to understand the details behind these steps. The last part of it is running the Streamlit function and viewing the output, which is what's happening here. Hey, it's me again with a quick outro. So hope you enjoyed this video. My plan is to explore all other interesting repos, build it, and then do some tiny tweaks to it. Like for this example, the changes that I made was I made changes to the Streamlit interface that was used. Like I changed the pictures of the human and robo face that the original authors had used. So yeah, the plan is to keep continuing these series. Before I wrap up, I just wanted to give a quick shout out to the original authors of the AWS Build On repo. The second shout out was to Ross and his JPEGs website for his amazing curation collection of those Fuji recipes. And one last thing is, don't forget to clean up all your resources. One tip that I follow is I have all the tabs open. Like if I'm working on Lambda, I have it open. If I'm working on S3, I have it open, so that I don't forget to close them out once I'm done with my project. So yeah, clean up, clean up, clean up. And I also want to give you a quick update on how much it cost me. So if you're going to do an exact reproduction of the original repo, it'll cost between 0.22 to zero point 0.4 cents. But yeah, just give a buffer of like $1. It, at the end of the day, it bottoms down to how many calls you're making to the Sonnet model. So yeah, that's the last tip that I had for you. Till I meet you again, this is Devi signing off. Bye.